Hey, everybody. Donnie here from Standing for Truth Ministries. And this is going to be a short video. I'm going to share my screen here as we get started. I should say shorter video. And now that the article that I have co-authored with Christopher Rupe is available, it's been out for a couple days. I wanted to make a short video for people who are not yet aware of this article. I would say it is a must read. You can find it right on the homepage here of the website. And so if you just click this, it'll take you right to the PDF where you can download it. The title of the article is Refuting Arguments Against Genetic Entropy. Does genetic drift solve the mutation load paradox? Christopher Rupe and I, Donny Budinsky. Christopher Rupe, he has written the book Contested Bones, the best book on the topic of refuting human evolution. And so I highly recommend it. I've actually got it up there to my right. And Christopher Rupe is very well rounded. He knows his stuff on all of these topics pertaining to the creation versus evolution controversy. He's well educated in genetics and population genetics, specifically, which this article focuses a lot on population genetics as it applies to genomic degeneration. So Contested Bones, firstly, I do want to recommend that book highly. It is the best book out there refuting all things human evolution. It's got very detailed, very comprehensive chapters on your Australopithecines, like Lucy, for example, Australopithecus afarensis. And there are many, unfortunately, even in the world of young Earth creation, that believe Australopithecus afarensis, or specifically Lucy, well, let's say the afarensis collection in general, is legit, a legit species. But this book has some really excellent information showing that your entire Australopithecine collection is really just a jumble of bones mixed. And so I highly recommend that book. He also gets into all of your human evolution icons, Neanderthals, Setiba. Unfortunately, there are many that think Australopithecus Setiba is also legit. Yoel Rack and Ella Bean would disagree with that. The evidence is strong that Australopithecus Setiba is also an artificial species. And so Contested Bones has a must-read section on that, and your other icons as well, Floresiensis, Naledi, Erectus, so on and so forth. There's also a genetics section in the book that goes into genetic entropy, goes into pseudogenes, the Gulo pseudogene, for example. It gets into the chromosome 2 fusion. And so point is, Christopher Rupe has done a ton of study on this, and so it really was a blessing, an honor, really, to be able to co-author this paper with him. So please check the website, download the PDF. You can also go to the blog section where I put articles and blog posts. Click here. This is just a couple paragraphs of me going into the significance of the article, and then the technical article down here you can read. So I do want to encourage everybody to read it. It really is the reality of genetic entropy. So genetic entropy is the concept. I just did a formal debate on this, a podcast debate with Taylor from the Snake Was Right YouTube channel. I've had over 100 debates, and genetic entropy is always a major focus of the majority of these debates, especially if it's on ancestry, because I've oftentimes pointed out that it's in genetics that we can best answer this question of ancestry. It's genes, traits, and genetics that are passed on sperm and egg every generation. Not a rock, not a bone, not geography, but genes and traits. And so it's in the world of genetics that we can directly answer this question of ancestry. And the reality of genetic entropy, again, it's the concept that the mutation rate is high, Specifically in humans, the mutation rate is high, but most mutations are what's called nearly neutral. They're not high impact enough or big enough to kill an organism, but they are slightly deleterious, very slightly deleterious mutations. And therefore they accumulate unchecked because natural selection, or in other words, differential reproduction, who's reproducing the most? Selection has to do with the death of individuals. And so if a mutation is not big enough or harmful enough or high impact enough to kill the individual and prevent reproduction, these mutations that are nearly neutral, they will go unchecked and undetected by natural selection. And so they are subject to genetic drift. They spread, they degenerate, they result in population-wide genetic sickness. But most importantly is they put shelf lives on genomes. And so if species cannot persist for millions of years into the future, they certainly could not have persisted from millions of years into the past. Another thing, genetic degeneration demonstrates young biology consistent with young Earth creation, but it also demonstrates a young Earth because we have layers of rock strata that evolutionists say go back millions to billions of years, but all throughout your geologic rock strata is what? Billions and billions of fossils, which represent extinct or dead biology in the past. So if today we have mutation accumulation putting shelf lives on extant organisms, but we have billions of organisms in the past as reflected in the fossil record, then that means the fossil record is also young. And so it really is a double whammy argument. And the critics have failed. Your most militant of critics have failed to address the reality of genetic entropy. That goes for all of the rescue devices: synergistic epistasis, mutation count mechanisms, truncation, selection, fitness variations, compensatory and adaptive mutations. I just put out an article about a month ago on the existence of bacteria and simple organisms. I've heard many try and utilize that as a way to hand wave genetic degeneration. And so that's been refuted sufficiently. And it's clear that the critics really don't have an answer. It's an unsolvable problem at this point, which means that it is preclusionary data. It precludes common descent from being true. And so it really is a fatal blow to common descent. But it's amazing confirmation of special creation and separate ancestry. But many evolutionists have gone back to the drawing board. And the new argument is, well, genetic drift can solve the mutation accumulation problem because most mutations are lost over time from genetic drift. And so this is where the article comes into play. And we really, really comprehensively address that rather weak and unimpressive counter to genomic degeneration. Now, I do plan to make a longer video in the future, probably next week sometime, going over the article in detail and addressing any possible objections that come in over the next week. But this one here, this is going to be shorter, just again to encourage people, motivate people to check it out. Okay, Chris and I have worked for several weeks, basically a month, in terms of all the brainstorming, getting it together, having it proofread, having it reviewed. And we've put a lot of time, effort, and work into it. It's been reviewed by many before being released, including Dr. John Sanford himself, who has coined the term genetic entropy. He is a geneticist. He has published in the secular journals over 100 times at least. And so he's reviewed it. He's approved it for publishing. I'm very happy with this article. It's rock solid, and it really does comprise arguments that even your most militant of evolutionists will dodge. And so this will take you to the article here. So again, refuting arguments against genetic entropy. Does genetic drift solve the mutation load paradox? The answer is no. And one thing that I've noticed is one specific critic, Dr. Zach Hancock, and I always appreciate how cordial and professional he is and how willing he is to engage in an intellectual back and forth on these topics of ancestry. But what I don't want to see the critics doing is reading the first 2 or 3 pages where Chris and I basically set the foundation for what is going to be discussed starting on page 6 with genetic drift to the rescue, and then the claim here on page 7. So if there are critics with rebuttals, counters, criticisms, I want them to put in the work. A off-the-cuff, knee-jerk YouTube comment or response is not putting in the work. It is not going to sufficiently address this comprehensive 11-page technical article. And so far, there's been no rebuttal. It's been a couple days, but there has been at least 1 or 2 comments coming in. And it is good to see that the PhDs, Dr. Stefan Frello, for example, who I've debated in the past, he's had a written debate with Dr. Jensen, and I've challenged him to another debate on this topic because he really likes being a keyboard ninja over Facebook, but he refused to debate again. And I understand why, because there's no good argument against the reality of genetic entropy. And so Dr. Frello on Facebook basically, and people can see it for themselves in these specific creation evolution groups, he's basically conceded, and he's gone back to synergistic epistasis, which has already been debunked sufficiently. And so to me, it looks like he's tapping out and saying, yeah, genetic drift is not going to solve the problem. So here's Dr. Zach Hancock, from my understanding, population geneticist. And so he'd be one of the best in the evolution camp to engage on this issue. But unfortunately, here, Zach, you can read it for yourself. Chris Rupe has corrected him and sufficiently addressed his arguments. But what Zach here, and I encourage people to read it for themselves, because this is the best they got. This is who a lot of your evolutionist debaters look to. They look to the Dan Stern Cardinals. Dan Stern Cardinal has already been proven to be out of date on this topic. I mean, he said Mendel's accountant doesn't account for or look at fitness variation. You know, I don't know who told him that, but that's absolutely ridiculous. All of these rescue devices have been looked at comprehensively. They've been systematically falsified. But you'll notice here, reading through it, for sake of time, I'm not going to go through it all. But what Dr. Zach Hancock here wants to ignore is the fixation of very slightly deleterious mutations using what we talk about in the first part of the article, Kimura's formulation. And that is what Zach here doesn't want to address. And it's kind of bizarre. I'm not accusing him of not reading the article in its fullness, but I'd recommend sitting back, relaxing, make a cup of coffee if you're a critic, read the article in its entirety. Don't read 3 pages and then give a knee-jerk response, because your side isn't going to look good. The evolutionist side, I'm sorry to say, and I mean this with the utmost of respect, it's just not looking good for the evolutionists at this point. And so far, it's been a fail to address this article. Okay, and so he wants to ignore this, which leads directly to mutational load. And Zach, he's a PhD, he doesn't want to acknowledge fixation of very slightly deleterious mutations at what we talk about in this article. So please read it. The fixation of these slightly deleterious mutations are at a rate equal to the neutral mutation rate. Every generation is having any relevancy to mutational load. And it tells me that some of these critics have tapped out. And so Chris Rupe here does a good job pointing out why it's not a bait and switch, because Zach Hancock here says it is a bait and switch, because he pointed out, I'll just say there seems to be a bit of a bait and switch in introducing Haldane's dilemma in relation to mutational load. And he gets into the Kimura and Haldane points that we brought up. But For clarification purposes, let me make this clear. And Chris Rupe points this out here in his comment. We were not describing Haldane and Camorra in the perspective of mutational load. We were simply setting the stage for why selection is limited. It is limited because of what? Because of the cost of selection. And so we are explicitly in the technical article, we are clearly referring to the process of substitution limited by reproductive capacity. And this is explained by us in the article clearly and thoroughly. And so the foundation in this article is set by first talking about Haldane and Camorra. And therefore, at this point, our arguments have gone untouched. They've gone ignored. And another thing Zach says here, he says, I would really like to see a mathematical model of genetic entropy that uses an empirically estimated distribution of fitness effects. As myself and others have shown, incorporating even exceedingly rare beneficial mutants with very small selective advantages are enough to overcome the mutational load for moderately sized populations. No, that is not the case. Firstly, Zach, you said you would like to see a mathematical model of genomic degeneration using a distribution of fitness effects. This has been done. This has been used. This is Mendel's accountant. Paper after paper, article after article has been published using Mendel's accountant, the most sophisticated numerical simulation of evolutionary processes that exist. And so unfortunately, and again, I mean this in the most professional way, I find that a lot of the critics, they're new to the party, but a lot of this has been looked at. Synergistic epistasis, for example, this has been dealt with. And so a lot of your evolutionists, they're backed up into a corner. And so they're using this genetic drift argument. That doesn't work either. Mendel's accountant, and I pointed this out in my debate with Taylor, it's user specific. You can input whatever settings you want, realistic or unrealistic. And when you input realistic conditions, guess what happens? Evolution fails and genetic degeneration is inevitable. And so, yes, you can take whatever mutation rate you want. Chris Rupe has run these simulations. He wrote a paper with Dr. John Sanford years ago on fixation rates, which I highly recommend people check out. And so, yes, take any mutation distribution you want. We had Dr. Rob Carter on 2 years ago, and he pointed this out. He's run simulation after simulation using Mendel's accountant as well. And he pointed out what I'm pointing out. These parameters can be applied to these artificial populations. You allow it to run its course. We look to natural selection. You can even set it in a way where your population mostly has junk DNA. And yet you find out over and over again with any realistic set of parameters, evolution doesn't work. Degeneration of biological organisms and systems, it's inevitable. And these beneficial mutations or adaptive mutations he's looking at doesn't work either. And so again, this has been done. Mendel's accountant, a wide distribution of fitness effects is used and considered, and it still doesn't work. And the simulations that somebody like Zach has done, and again, I appreciate his time, I appreciate his efforts, and I appreciate him keeping this cordial and professional, but they're simply too simple. It's as easy as that. You need to have realistic parameters. I've actually got a couple slides on this. And right here, for simulations, realistic parameters must be used. Simplified numerical simulations won't give honest results. What do we know? Verified over and over again by evolutionary population geneticists. Mutations are overwhelmingly deleterious. Most mutations are subtle, and they get lost in the noise. They go on unchecked. Selectable mutations are those that are high impact, but it's not about the high impact mutations. And this is a problem here that I have with Zach Hancock's comment over here, is he said, this has been observed in real systems as the proportion of deleterious variation being harbored. But he's talking about small populations. But he says for even moderately sized populations, we see no evidence of substantial mutational load. Well, firstly, humans, the human population is manifesting a lot of mutation-related diseases. A lot of it has to do with environment. Dr. John Sanford, I've got it upload on my channel at the National Institute for Health, not a Young Earth Creationist organization. He gave a lecture on human genetic deterioration. And he pointed out that cancers are on the rise. It's about 1 in 3 autoimmune diseases, immunological diseases. Autism clearly has a genetic component to it. And so we have this pandemic of degeneration in humans. This is clear. Again, you can't take humans back a couple 100,000 years to millions of years if you want to go to precursor ancestors in light of the high mutation load. And they're going to want to look to relax selection. If I had $1 for every time these critics said, well, humans are degenerating, they're not getting any better, because even they recognize humans, the most studied species, especially genetically, how many billions of dollars has been put into studying the genetics of humans, our species, our existence. And we're finding ample evidence for genetic degeneration, but these evolutionists that respond with relaxed selection ignore the key problem, which is firstly the fixation of these nearly neutral deleterious mutations, but also the fact that the high impact mutations, the ones that are big enough for selection to see, a single point mutation can kill somebody. Selection has removed that individual from the equation. In the wild, for example, there's selection in terms of the high impacts are stronger. Say a zebra is born with one leg too small, let's say. Well, you know what? That zebra's probably not going to go on to reproduce and pass on its genes, because that zebra is going to be dinner for the lion, because the zebra is not going to be able to run very fast. It is a mutant in the sense that the lion is going to choose that zebra for dinner over your zebras that don't have that high impact mutation. But in humans, you can have a high impact mutation, for example, like that. But yet we take care of the sick. We help each other out. We have medical advancements. And those are good things. And so a lot of those high impacts may thrive in the human population, but it's about the low impact, nearly neutral, and very slightly deleterious mutations. Those are the ones that build up, they go unchecked, unnoticed. And so anytime these evolutionists look to relax selection, they are ignoring the fact that it's not about the high impact. Yes, selection can see the biggest mutations, remove the biggest mutations from the equation. Selection may even be able to, in light of all the noise, see a rare so-called beneficial mutation, even though Walensky's experiment and all these studies on beneficial mutations has demonstrated that even your best beneficials are usually reductive and functionally compromising to organisms, the organisms that they occur in. And so, sure, selection may be able to amplify your rare beneficial mutation, even though that beneficial mutation that's amplified, sickle cell anemia, for example, is due to a broken pre-existing protein or cell. So it's still reductive and there's no real counterbalance. And sophisticated computer and mathematical modeling has demonstrated this. And with Mendel's accountant, this program, it's been tested, it's been validated in the professional scientific literature, and it has not been represented well by the critics. This entire presentation I am going to do, again, a whole video on in the future, but I just wanted to show you that there are several papers here. Dr. Rob Carter himself has addressed a lot of these critics. For example, this is Dr. Dan Stern-Cardinal, and Rob says he wraps up his criticism of genetic entropy with a real whopper. I agree. I cannot see how he drew the conclusion. Yes, I agree. And a lot of these conclusions that I'm seeing from Zach Hancock in his videos and comment here is the same thing. Even in bacteria, we're seeing evidence for reductive evolution, because Walensky's experiment, the long-term evolution experiment, these populations of bacteria, they have evidence. Dr. Sanford pointed this out in his NIH lecture for genetic degeneration, a form of genetic entropy. They've been backed into a corner, these populations. They've shrunk in functional genome sizes. They've lost a lot of genes for short-term adaptive purposes, but it's actually long-term degeneration. It's like if I wanted to get better gas mileage in my car short-term, temporarily, I could start removing weight from the car. Remove the seats, remove the side mirrors, remove whatever it is in your car that can reduce its weight. And so you're destroying the car, you're removing things from the car, and temporarily get better gas mileage. But over time, that's not good for your car. It's actually damaging your car. It's making it worse. And that's what we see in bacteria, is evidence for reductive evolution. So even in bacteria, we see evidence for genetic degeneration. But genetic entropy was written for longer lived, higher and more complex organisms like elephants and humans. And we see plenty of evidence for genetic degeneration. These subpopulations, especially in your fossil record with Neanderthals, Floresiensis, the Hobbit, right, Naledi, Erectus, we see significant evidence for genetic degeneration. There's papers on mammoths. These mammoths carried a high genetic load. This is microgenetic entropy, essentially, because in smaller populations, a lot of these recessive deleterious mutations, they're going to come to the forefront faster and lead to rapid and accelerated genetic degeneration. But in a large population, let's say in humans with 7 to 8 billion people, 100 new mutations per person per generation accumulating. Therefore, you have, and this is where I wanted to address another point that he said here. He talks about what you and Christopher refer to as multiply mutant is a sign of reduced drift load, not greater. That's why species of most conservation concern have very little diversity, mostly not mutant. In fact, conservation genetics relies on measures of genetic diversity to determine the health of a population. So problem is, let's take humans. We say that every single human is multiply mutant. Yes, that's because every single human on this planet has accumulated more mutations than their parents and grandparents. Every human has a complex array of mutations, especially deleterious mutations. And the problem is, and I'll use an illustration or an analogy. Let's say you have a room full of people. Let's say 100 people. Everybody has mutations that they've accumulated. Notice this on the slide. Every chromosome has a complex array of nearly neutral and deleterious mutations. Each chromosome also comprises rare beneficial mutations, but the interactions between these countless mutations means selection is inefficient to solve the degeneration problem. Since we have, as a population, an increasing genetic load, selection simply cannot sort out the good, the bad, and the ugly. And this is the point that we make in the article. Selection is what? Selection is limited. Fixation or genetic drift's not going to work because you're nearly neutral. Your neutral mutation rate over a long time equals your fixation rate. And a lot of your other mutations, they're floating around the population, still degenerating, still leading to disease, and they don't have to drift to fixation to result over time in genetic sickness in whatever the respective organism is. And that's what a lot of these critics, unfortunately, miss out on. And so if you had a room full of 100 people, every single person is multiply mutant. That is a very proper way to describe the human population. 7 to 8 billion people, everybody on the planet has accumulated thousands of mutations. And so let's say we were to invoke really strong, unrealistic selection. Let's remove 50% of the worst mutants, the ones with the most damaging mutations out of the 100 people in that room. Okay, so you remove 50 people. What are you left with? Are you solving the degeneration problem? No, you are not, because you're still left with what? You're still left with 50 people who are still more mutant than the generation before it, because those 50 people still have more mutations, roughly 100, than their parents and their grandparents. And so all you can ever do is slow down the degeneration process. Notice this: realistic parameter settings demonstrates that genetic degeneration is inevitable. This has been published in numerous secular journals. And so those are just a couple points that I wanted to address from Zach. I wanted to highlight this comment from Chris Rupe, and I appreciate it. He really is a blessing here. And so he says, our article makes it clear why we discuss the findings of Haldane and Camorra, which really made me wonder if you read the article carefully. See, that's what you need to do. Is it'd be like if I had an opening statement 15 minutes into, I've done a number of debates and I know how to write an opening statement and I know how to write a strong opening statement. And a lot of times, let's say your first 8 minutes is really setting the foundation for your major points that you are going to hammer your interlocutor with in your second half. Well, it would be like an evolutionist basically thinking that they've won the battle by only addressing the first 8 minutes, but then ignoring everything that the first 8 minutes set in terms of the foundation for your major arguments. So we want the critics to read the entire article, take your time, and if sophisticated, we're more than happy to respond over time, because we do have a lot of other things going on. And so he says, Camorra referred to the work of Haldane as part of his rationale for devising his neutral theory of evolution. Of course, Camorra based his theory on his own findings as well, using amino acid sequence data to determine mammalian substitution rates. He goes into our article and talks about how very slightly deleterious mutations, which are effectively neutral, become fixed via genetic drift based upon Camorra's formulation. And we wanted our critics to understand that since these, again, that stands for very slightly deleterious mutants, become fixed in the genome via genetic drift, it is directly relevant to the mutational load paradox because they do not respond to purifying natural selection. I don't know how you can't see the logical transition in thought there from Haldane to Camorra, but guys, it is there. I encourage you to read the article, read it objectively, read it in its entirety. You will see that genetic entropy is a fatal blow to evolution, and it is amazing and undeniable confirmation of special creation and separate ancestry. Genetic entropy demonstrates that we are not the result of millions of years of evolutionary processes. We are actually the result of special creation just thousands of years ago and not millions of years ago. Okay. And so I'd recommend you can check these out. But most importantly, guys, check out the article right here. You can download it and find it in a couple different spots. I've also posted it in our secondary channel, Young Earth Creation. So you can find it there. One thing I'll say is here on the Standing for Truth channel, one of our videos went viral here. And so I wanted to thank everybody. We just hit 14,000 subs. In our video here on the worldwide flood, we've got another one. This is up to 213,000 videos. And so thanks to all our supporters. Thanks for, helping us get to the 14,000 subscribers. You guys are the life and blood of this channel. And so I've posted it on the Young Earth Creation channel, the Standing for Truth channel. You can find it here, linked here, right on the main page. And you can find it in this blog post. And read it carefully. Lots of good information here for you. And it basically leaves no stone unturned. And it demonstrates again why the rescue mechanisms employed, advanced, put forth by the critics, they simply do not work. And with that, guys, I am going to wrap this up. Please, I encourage you, read the article and stay tuned. I will be doing a much longer video. I'm actually at the 35-minute mark, which is more or less where I wanted to complete this video on. And so God bless. Thank you for tuning into this video. Please share this around. Share it around on Facebook. Share it around to your friends, your family. This information is important, and that is because the truth is important. God bless.